Beginning of December last year, I was doing a bit of a search around on eBay, seeing if I could find any old, sort of like the 1970s analog multimeters we used to have when we were younger. And I remember a couple of them, particularly one that a friend had when he was at school, that I was always pretty taken back by. I had no idea what make it was. All I remembered was what it looked like. And I was sort of just doing a search really just to see if I could find a meter that looked very similar. And I don't know if I showed this to you before, but this is the meter that he had. I found one on eBay. These come under a number of names. This is a YFE, which is quite a well-known Taiwanese make. And this meter was, I bought this very cheaply. It wasn't listed as a multimeter, it was actually listed as a panel meter. So I bought this and it was in filthy condition, but it cleaned up really well. And I'm just intrigued by these old meters and just really interested to see what they were like internally and how well they performed. Now, when I got this particular analog meter, the meter wasn't working. It was sold as a non-working multimeter, so I was expecting it not to work. But I thought he didn't specify what was wrong with it. He just said it didn't give you the correct readings. When I got it out of the box and sort of unwrapped it, apart from the sort of filthy, it obviously been sitting in someone's toolbox for a while, the meter movement was there was a bit of movement in the meter, but it was stuck. So I applied a couple of volts to it and things like that, and the meter just sort of stuck less than eighth of the way down this dial, just stuck. So it's clearly a problem with the meter movement, but there was no sign of anyone being inside and breaking it open or anything. So I thought, oh, it's a nice little meter. I'm going to see if I can actually get the meter moving. So I just basically took the unit apart, took the cover off, and the spindles had been either not tightened up properly, or someone had been in here fiddling around with it. A lot of messing around on the pivots and things, and actually got the meter movement to work. And surprisingly enough, I mean, I know it's not showing at 0 now, but when it's lying flat it does. This meter is incredibly accurate. Now bear in mind, these meters are 70's technology. They've got very little, if no, over voltage protection or overload protection. All they have is a couple of germanium diodes across the meter to prevent the meter from burning out, but that's a sort of not necessarily going to happen. There's a good chance that if you over voltage them, it's just going to blow the diodes up and still burn the meter out. So you have to treat these with extreme care. I wouldn't ever recommend these meters for anything more than sort of like battery voltage testing or sort of low voltage testing. But it works. It's a nice little meter, and I think they look great. I think they're real retro style. So I thought, well, let's buy another multimeter. Let's get another one. I found another one in the States, a company called Midland, who are quite well listed, and I ordered that, as I say, in the beginning of December last year, and waited for it to turn up. I mean, obviously coming from the States, it's going to take a while. Nothing ever turned up. So the middle of January, no, what was it, the beginning of December? So I think it was actually the beginning of November. Yeah, it was the beginning of November. That's when I ordered it. Beginning of November, nothing turned up. So in January, beginning of December, I rang up eBay or communicated with eBay through email and said, look, this thing hasn't turned up. I think it's a live chat, and said, you know, it hasn't turned up. It's stuck in the US Customs. So this chap went offline and said, oh, you know, it's got stuck in US Customs. You're not going to see it now. It was stuck on I think it was the 9th of December it got stuck in there. The last track was 9th of December, and it hadn't moved for like 3 weeks. He said, you know, you're not going to get the meter, I'm afraid. He said, you know, this happens quite a lot actually. He says, particularly this time of year, Christmas time, stuff gets lost. I said, well, what am I going to do? I said, you know, I mean, it wasn't a huge amount of money. I think it's $35, including the postage and things. He said, well, don't worry about that. We said, I'll refund you. And you know, and I was very apologetic, and I was very pleased with the service. I said, oh, it's a shame. It's going to be a nice meter. Anyway, he refunded me. And I tried to communicate with the person who's selling it, saying, have you any idea if you've got any more tracking information? And I tried 3 times to communicate with them, and they didn't even respond to my emails. So he gave me a refund, as I say, and I left the neutral feedback for the seller, saying, okay, it's not your fault it's got lost, but it hasn't turned up. And if you communicate with me and say, I'm sorry, I don't know where it is, I would have given you positive feedback. But no communication, you don't get any good feedback. I think that's fair. That's what the communication is there for. It was a well-established seller. Maybe they're thinking, oh, for the price I paid for it, I can't be bothered to deal with you, sort of thing. I don't know. For the price you paid for it. So I did have a quick look on the sort of like the eBay forums and things. And they're saying what often happens is if the person sort of sells the meter to you and the postage is really cheap, which it was, when it gets to the sorting office in the States, they won't ship it for the price that they put the postage on, and what they'll do is they'll just sell it on as a local auction on eBay. So I'm thinking, that's probably what's happened. Well, today I got someone rang me up and said there's a parcel in the reception for you, and I was thinking, I'm not expecting anything, that's unusual. Anyway, I sort of wandered over there, and there's this sort of little square box turned up. And I was thinking, I can't remember if I've ordered anything. So anyway, I sort of popped it in my car, and I sort of had a quick look at my phone and thought, no, I've definitely not ordered anything. What the hell is that? So I got the box out of tea break and sort of looked at it and thinking, that's that bloody multimeter that's finally turned up. And sure enough, long story short, I suppose, this is it. Now, I don't know what happened. The last tracking was seen in the States in the sorting office, and that's the last anyone saw of it on the 9th of December. But it finally arrived in the UK, and this is it. This is a little Midland multimeter, very basic, and similar style to this Taiwanese meter. Pretty sure they're a copy, and that's one of the reasons why I bought this meter, because I was intrigued to see what this meter was like inside. So it came with a set of leads that looked like they've never been out of the packet, plus another set of leads, which is great because this meter hasn't got any leads, and it uses these small type uninsulated, non-standard type sort of leads now. And I was looking for a pair, and I couldn't find any on eBay, but looks like I have actually found a pair that will work on this meter, so chuffed to bits with that. So this is it. It turned up, and sure enough, I don't think this meter's ever been used. There's no marks on the back. It's in lovely condition. It's a very, very basic meter. It's nothing special. Again, I bought it because I think they look so cool. I think there's something so retro about this sort of like this half quarter sort of circle meter dial. So this is made by a company called Midland, and it is made in Japan, according to the paperwork and things. Very basic. So we got 5 volts, 25, 125 and 500, sorry. And then we've got 2.5 kV, which I'll be very dubious about using. So that's your 2.5 kV terminal there. We've got a couple of ohms ranges, very basic, times 1 and times 10 and times 100k. 1000 volts, 250, 50 and 10 on the AC volts, and on amps we've got 50 microamps and 250 milliamps. So these are the ranges you're going to cause serious damage to this meter if you didn't connect it up right, because like the other meter there is very little protection. I'll just take the back off in a minute to show you. So a couple of other things. This is obviously your ohms adjustment pot, and basically the volts and the current share the same terminal, so it's very easy to get the scale on the wrong range and damage the meter. You have to be very careful with it. It's not like the flukes, where the flukes have sort of like protective sections where the current is on a totally different connection, and on a later fluke, if you plug the voltmeter, the leads into the common and the amps range, and you're on volts, it will beep at you to warn you don't connect any volts to it, because it's in series mode. So it wants to measure current, not volts. So don't go and put check your car battery when it's plugged into 10 amps range. Alright, they are protected, but it's not going to do the meter any good. Unnecessary duress on the meter. You haven't got this protection on these meters. You have to know what you're doing, you know, and that's why there's probably not many of these meters about, because most of these have ruined. And I'll tell you a little story actually. An AVO meter that we had at work, an AVO 8. When I first started at the company I'm working at now, or in the test department, I was working with an AVO 8 measuring the mains voltage. One of the other readings I had to do was measure the input current. And you know what the story is, don't you? I don't know if you know, AVOs have got an overload cutout switch on them. And basically what that overload cutout switch does is when the meter goes to full deflection, there's a little pin that the meter hits, that the pointer hits and trips the overload cutout out and breaks the circuit, and that's great. They do work very well up to a point. Unfortunately, I did what I was just mentioning earlier on. I had it on the 10 amps range, and I didn't notice. Switched it on, put the power on, and I've told you this story before, but it still amuses me and amuses other people. Turned the power on, I thought, that's strange. The display's gone black, and this display just went just totally black. And I was thinking, you know, I've only been in the job about two weeks. I thought, oh great, that's a good start. And I thought, oh shit, you know, how am I going to explain this? So like a £500 meter, and the dick's just plugged it into the straight across the mains. Anyway, I told my boss, who's a good friend of mine now, and I said, Steve, I think I've buggered your meter up. And I think he called me a few expletives and said, "Oh, don't worry, we'll send it off and see if we can get it repaired. In the meantime, just don't do it again." But that's what can happen with these meters. It's easy to damage them. So let's cut the waffling back a bit and show you inside. Oh no, I haven't explained this output. I bet everyone will say, "What's this output socket, Doug?" This isn't an output socket. Don't think it is. All that is a series capacitor. And if you're measuring AC and you want to remove any DC components, if you're measuring AC, you just use the common connection and the output capacitor. It's exactly the same as putting a capacitor in series with this. It blocks any DC component, gives you a more accurate sort of reading on the display. So on the back we've got a single screw, and that allows us to access to the battery compartment and the inside. So let's have a quick look inside. You can see there's no marks on the back, it's in lovely condition. Pop the back off, and here's the inside. Well, it didn't come with a battery, there was nothing attached, and it really doesn't look like this has ever had anything inside it. Very simple design. The switch, as in with the Taiwanese meter I showed you earlier on, the switch is lovely. It's got a real nice, solid, chunky feel to it. Lovely built quality sort of switch contacts. They're not going to become noisy quickly, they're not going to wear out. So that's a really nice nice switch, nice build quality. Wire round resistors for the low values. These are the sort of things that you often find in these meters that are burnt out. Let me just zoom in a bit so you can see a bit closer. So we've got these old wire round resistors here. These are all pretty high precision resistors, should give you a fairly accurate reading on all the ranges. Here's our pot here on the back of the pot. There's that big capacitor I was telling you about that acts as a DC block for your AC component measurements. That's obviously the back of the meter with the movement inside that you can actually sort of take that off to clean it should you need to. You shouldn't ever need to take these apart once they're in there. Obviously only 1.5 volt battery, that's why it doesn't do the 10 ohms range, because it hasn't got enough voltage to overcome the voltage drop through the resistor, that sort of thing. Yeah, and that's basically it. Minimalist meter. We have got here a couple of diodes. This little red thing here is probably it's a double diode, almost like a bridge, and like two diodes back to back. And you can see connection there, and there. So there's your meter connections on the side, and that's where your supply comes in, and that's giving you protection to the meter. So basically, if it approaches more than about 0.2 or 0.3 of a volt, this diode will conduct and sink the current through these resistors and prevent the meter from having to take all the current. It does work to a degree, but it's you still need to know what you're doing. You know, you can easily blow this thing up by just putting too many volts in and damaging it. Whereas on a modern meter, you clearly won't do that. You've got much better protection on a good modern meter. That's to say, not a rubbishy modern meter. So let's give it a couple of, let's put the back on it again. Just no, I'm trying to see if there's any sort of where it says made in Japan. It does say there, you can see there it's got 2 joules in it, which is nice. So it's obviously a joule meter movement. So it's fairly low friction meter movement. We'll pop the screw back in, and we'll just do a couple of very basic checks just to see its overall accuracy and see if it's anywhere near the ballpark. Now these meters, they're not super accurate. They are designed to give you an idea of what sort of voltage. You're not going to use these for accurate measurement. You can't use them for accurate measurement. They're just not up to that sort of, they're not specified. I think they're usually at about 3 or 4% maximum. So let's connect our meter leads up and make sure we're on DC volts. Okay, and what I'm going to do is I'm going to connect my external power supply to, I think we'll set it to, we'll probably set it to 20 volts, something like that, and we'll see what we get now. Parallax is always a bit of a problem with these meters, especially when you're using a camera, but I'll set the power supply up to 20 volts, which is there. We'll connect our meter up. Okay, so that's 20 volts. So let's bring you down and have a look now. You can see it's saying it's slightly shy of 20 volts. Now that could be probably corrected by resistor changes, but at the end of the day, we're not really that interested in how accurate this meter is. That probably hasn't got any worse with age. It might actually improve slightly with being used, I don't know, but you can see there, if I'm looking at the meter directly above me, it's saying about 19 volts. And I'm definitely putting 20 volts in, so it's not bad. We'll try check it for scale linearity. Let's go to 10 volts. That's 10, and it's slightly over on 10. So the scale calibration isn't that great. Just try and get you above the meter so you can see. You see, it hasn't got a parallax mirror, so they're probably not expecting this meter to be particularly accurate in the first place. So I'm not going to check any. Oh, we could check AC mains voltage, I suppose, and see if we don't blow ourselves up. It'd be a good test to see if the meter's insulation's okay without killing myself. So, got a wall socket here. Don't do this at home, please. You know, I don't want the responsibility of you electrocuting yourself, unless you obviously know what you're doing. If my dad saw me doing this now, he'd have a heart attack. He used to be terrified. He used to think that everything I touched would blow up. It's reassuring from your father, isn't it? And there's your power supply socket here. So I'm going to put one in here. Just check we're on AC volts. We're not going to blow anything up. Stick it in, and we've got just under full scale deflection. So that's saying 230. It's probably about right. 220, 230 volts. So AC range is working fine. That's good. And we'll do a quick ohms check just to see if that's anywhere near right. So we should have probes out and get our meter to 0 ohms, which is more or less there. So let's grab a resistor. Let's grab a 300 ohm resistor. And that's pretty good actually. 300 ohms is right in the middle. I can't really hold you on. Can I hold you on so you can see? There you go. So it's 300 is pretty spot on actually. So clearly working fine. Meter's good. And I'll just demonstrate this blocking capacitor quickly. If you've got it on DC volts, obviously, and you've got a capacitor in series, all you're going to get is a twitch on the meter, and then it will just go back to 0, unless of course the capacitor's leaky, which is possible. So we're on DC volts, connected out. You should see a meter briefly just twitch. Zoom you in a bit so you can see the meter. Yeah, let's bring you in before it goes out of focus. That's quite good, isn't it? Just touch it. You see a brief twitch. If I short it out, it should go the other way. There you go. So the capacitor's okay. And we can check that by going to 5 volts. Yeah, the capacitor's working. So the DC blocking capacitor's fine. I don't know what the capacitor's rated at. Probably about 1000 volts, but I really wouldn't mess around with it, quite honestly. If you, as I say, with these meters, don't use them for sort of high voltage or anything that's slightly dangerous. They're not really up to it. You can buy yourself a cheap Chinese meter that will probably work just as well. So yeah, that's basically what it is. 2 meters I was interested in buying, and it comes with its little pocket book here, which is nice. Let me just show you the pocket book. It's so it's your Midland 23/101 volts ohm milliammeter, operating instructions, and there we go. It's basically how to use it, precautions on take extreme care when measuring current and voltages on high tension circuits, things like that. You know, pretty obvious stuff to people who've done this stuff before. Don't apply voltage to the ohms range. You know, when you're checking ohms, make sure you calibrate it first with the ohms adjust knob. And there's a little circuit diagram at the back for how the thing works. There's those diodes I was talking about that protect the meter. What you can do, and I need to confirm this actually, but one thing I was thinking of doing, I don't know if it's going to affect the AC reading, is putting a very low voltage, high value capacitor across the meter. Because the meter is running through a series resistor, it will give you a time constant. So if you apply a high voltage, the meter will come up slowly. It will dissipate a lot of power through the resistor, which is only a 3K, which should be okay, but it will give you a chance to see that the voltage is coming up and it's going to go off the scale pretty quickly, and you know you're overdriving the meter. And that basically means that the meter's not going to go patwang and just bust the needle, which you've seen that before. If you could look on listings of second-hand meters that people are trying to sell, you often see that the meter's sort of like not started at zero, it's got a sort of like a bend in it, so that may protect the meter from further damage. Yep, so that's the little Midland multimeter. I wanted to show you these because I think they're cute. I know that most people aren't interested in stuff like this, but a bit of history means a bit to me, from, you know, using these sort of things at school and going out and buying with your pocket money, buying a meter. That they wouldn't have been that cheap, these meters. They've probably been 15-20 quid, something like this. A lot of money to a schoolboy. So got quite fond memories of these things. Anyway, that's it. Thanks for watching.